When you hear about the AI race, the story pretty much always goes like this. Bigger is better. We hear about these absolute giants like GPT-4 with trillions of parameters, and you just kind of assume the future belongs to whoever can build the biggest, baddest model. But what if that's only half the story?
And that's really the big question we're diving into here. Because while all the headlines are obsessed with these massive models, there's this quiet revolution happening in the background. It's being driven by their much smaller, more focused cousins.
Okay, so take a look at this number. Over 125 million. What do you think that is? It's the number of monthly downloads for one of the most popular AI models on Hugging Face. You're probably picturing some brand new, cutting-edge, massive model, right? Well, surprise, that model is BERT base. And by today's standards, BERT is considered, well, small. So there's this huge disconnect, isn't there? The giants get all the press, but it's these smaller workhorses that are actually being put to work on a massive scale. So what's really going on here? To really get it, we need to break down the key players in this whole ecosystem and the fundamental differences between them. It's not just about size, it's about what each type of model is actually built to do. So let's get our terms straight. On one hand, you've got the large language models, the LLMs. These are your GPT-4s. On the other, you have small models, or SMs, like BERT. But here's the crucial thing. Small is totally relative. I mean, a Llama 3 model with 8 billion parameters is absolutely huge compared to BERT, but it's a lightweight next to something like GPT-4. It's all about the scale we're talking about. So you see, it's not about just picking the best model, period. It's about understanding that there are these fundamental trade-offs, and it's all about picking the right tool for the job. This table lays out the core trade-off perfectly. LLMs, they're the general-purpose powerhouses. They've got state-of-the-art accuracy, no question. But all that power comes at a huge cost, and they're often a total black box. Good luck figuring out why they gave you a certain answer. Small models are basically the mirror image. They are super efficient, fast, and you can actually explain their reasoning, which is absolutely critical in fields like finance or medicine. The catch? They're built for very specific jobs and can lag behind in just raw general performance. But here's where the story gets really interesting. It's not always a competition. In fact, some of the most powerful AI solutions out there actually involve large and small models working together, side by side. So the first way they collaborate is when the big models act like teachers. There's this brilliant technique called knowledge distillation. And the idea is actually pretty simple. You use a big, powerful model to train up a smaller, much more efficient one. Think of it literally like a teacher-student relationship. You have a big teacher model that creates this really rich, detailed set of examples, and then a smaller student model trains on that data, learning to mimic the teacher's thought process. The end result? You get a compact model that keeps a whole lot of the original's power, but is way, way more efficient. A really famous example of this is DistillBERT, which is just a faster, lighter version of BERT. All right, now let's flip the script. It turns out small models can also make large models a whole lot smarter. And this is where a technique called Retrieval Augmented Generation, or RAG, comes into play. Let's be honest. A huge weakness of LLMs is that they can hallucinate. Just make stuff up, or use information that's totally out of date. RAG is designed to fix this by pairing the big LLM with a small, speedy fact-checker that can go out and retrieve external, up-to-date knowledge. So here's how it works. When you ask a question, a small retriever model first zips through external documents or databases to find relevant facts. It then hands this fresh, relevant context over to the LLM, which uses it to generate a much more accurate and reliable answer. Basically, the small model does the research, which makes the big model's final output so much better. So we've seen how they can work together, but what about when they compete? Well, there are definitely times where small models aren't just a cheaper option. They are the clear winner, especially when we step out of the research lab and into the real world of business. Research shows there are 3 key situations where small models really have the edge. First, in environments where you don't have a ton of computing power, like on your phone or some other edge device. Second, for highly specific jobs where what you really need is efficiency and precision, not broad general knowledge. And third, in situations that demand high interpretability, where you absolutely have to be able to explain how the AI made its decision. This quote from a case study with small and medium-sized businesses just nails the point. They found that these big general AI models were, in their words, insufficient for managing their own internal workflows. And why? because of semantic gaps. The general models just didn't get the unique language and nuances of their specific business. This is exactly where a custom-trained small model would be perfect. And that gets to the heart of it for most businesses, right? They're dealing with tight budgets, they don't have an army of AI experts, and they have really critical needs around data privacy and transparency. For them, using a massive black box LLM is often just not practical. A smaller, more efficient, and understandable model is simply the better and, frankly, safer choice. So, after all that, what's the big takeaway? How should we really be thinking about the future of AI if it's not just a race to be the biggest? First thing to remember, the future of AI is not going to be a monopoly of giants. This whole idea of one massive model to rule them all, it's being replaced by a much more interesting, much more diverse reality. Instead, we should really start seeing AI as a diverse ecosystem of tools. You've got big models and small models, generalists and specialists. And success in this new era isn't going to come from just always defaulting to the biggest model you can find. It's going to come from developing the skill to choose the right tool for the specific job you need to get done. So the next time you're thinking about an AI project, ask yourself this simple question. Does this problem need a sledgehammer, or does it need the precision of a scalpel? The answer to that will tell you pretty much everything you need to know.